Okay, we're going to be looking at something called trig identities. Trig identities as an exercise is when we try to prove that one trigonometric expression can be written as something else using some standard identities. The first of which is sin x divided by cos x is equal to tan x. Now, that's National 5 material. You won't be given that in the formula sheet. You need to learn that one. Now, a second identity that you absolutely need to know from National 5 is the fact that sin squared plus cos squared is equal to 1. Now again, that is National 5 content, won't be given to you in a formula sheet. It's essential that you remember those two trig identities. Now, the next thing is, what's also essential is being able to work with this one, sin squared plus cos squared equals 1. If I was to bring that across, that means I could write sin squared x is 1 minus cos squared x. That's also important that you know how to do that and even learn it off by heart even better. If I was to move that across, I could write cos squared x is equal to 1 minus sin squared x. So I would really advise that you remember these off by heart. Okay. Now, what we're also going to bring into the mix is the addition formulas for sin and cos. So remember that it's sin A plus or minus B is sin A cos B plus or minus cos A sin B. Okay, so that's two formulas in one. So when it's plus, but when it's minus, it's minus. And then we've got cos A plus or minus B, and for cos it's cos A cos B, sin A sin B. Now the difference with the cos expansions is you can see that it's plus or minus in the middle, so you flip that. So when it's plus it becomes minus in the middle, when it's minus it becomes plus. So we're going to use those as well. Those will be given to you in the formula sheet. Okay, so let's just crack on with an example then. Let's try an example 1. So, example 1, I'm going to prove that cos 90 plus x can be written as minus sin x. Well, the first thing to say here is that I'll need to keep in mind that I've got exact values that I should remember. That's going to be essential. Okay, so let's have a go. So your cos expansion is going to be cos, sin. There's a plus in this expansion, so that's going to be a minus in the middle. So it's going to be cos 90, cos x, minus sin 90, sin x. Okay, then we need to extract our exact values, and this is one of the 15 exact values that you need to know, as is that one. Okay, so cos 90 is equal to 0. So that's going to be 0 times cos x, which will just collapse down to 0. And here I've got sin 90. Well, sin 90 is equal to 1, so that's going to be minus 1 times sin x. And there we go. It's proven. I've written it as minus sin x. Question done. Let's move on to an example 2. Okay, example 2, let's go for, we're going to have a go at proving that sin alpha plus beta divided by cos alpha cos beta can be written as tan alpha plus tan beta. Okay, well the first thing that I would look at and say that I can do something with that is the sin plus expansion. So let's open that up. So it's going to be sin alpha cos beta, this is straight from the formula sheet, plus cos alpha sin beta, all divided by cos alpha cos beta. Okay, now my next move is I can split this into two terms. So it's going to be sin alpha cos beta over cos alpha cos beta let's do the second one, plus cos alpha sine beta over cos alpha cos beta. Okay, now let's see if we can simplify this thing down. The first thing that I'm going to look for is to cancel things out. So I can cancel that and that. I can cancel that and that. And the next thing that I'm going to remember is that sine over cos is equal to tan. So sine alpha over cos alpha is tan alpha. So again, it's essential that I can recall that information immediately. And then sine alpha over cos beta is tan beta. And let's have a check. That was what we're looking for. Okay, let's try an example 3. Okay, next one we're going to try might be a wee bit longer, maybe a wee bit trickier. But let's stick with it and see where we go with it. Okay, so we're going to prove that cos A plus cos B all squared plus sin A minus sin B all squared. Okay, let's just head that up. We're going to prove that that can be written as 2 bracket 1 plus the cos plus expansion cos A plus B. Okay, so let's just take one line at a time, one thing at a time. Okay, we can see here that we've got a squared bracket, so I'm going to just write that down and repeat the bracket. Okay, so the key thing is with these questions is just take it systematically, one step at a time. So that's going to be cos A plus cos B times cos A plus cos B. And then that one is going to be sin A minus sin B bracket sin A minus sin B. At that point, I'm going to just use a bit of National 5 stuff, which is just what would be my tactics for expanding that out. Well, it's just going to be the same tactics. So that's going to be, well, I'm going to use FOIL method. You might do more of the kind of loop thing, but whatever. Okay, so I'm going to go FOIL. So cos A times cos A is going to be cos squared A, so that's cos A times cos A, it's written as cos squared A, that's how we write it, remember. Okay, then cos A times cos B, well that's just cos A cos B. And then cos B, so that's the firsts, outsides, insides now. Cos B times cos A is cos B cos A. And then the last are cos B times cos B is cos squared B. Okay, I'm now going to add on this double bracket. First, sin A times sin A is sin squared A, outsides sin A times sin B, and there's a minus in the middle, minus sin A sin B. Okay, and then minus sin B times sin A. Okay, so none of this is particularly difficult, it's just quite long. Okay, and then last, minus sin B times minus sin B is going to give me plus sin squared B. Okay, so let's see if we can collect some things together to get going. Okay, that's not very clear, so that is cos B. Okay, now remember that AB is the same as BA, just in the same way as 3 times 4 is the same as 4 times 3. So what I've got now is cos A cos B and cos B cos A, so they're the same thing. Okay, so I'm going to first of all collect together the cos squared A, and is there anything I can collect that with? Well, no, there's no more cos squared A's, so what I'm going to do is I'm going to collect that together, I'm going to score that out and then collect it with cos squared B. Okay, I'm then going to do my sin squared A. and my sine squared b. Okay, I've then got crossing things out as I go, because that just helps me account for things. So I've got cos A, cos B, and cos B, cos A. Well, they're the same thing. That's 2 cos A, cos B. And then I've got minus sine A, sine B, and then minus sine B, sine A, same thing. So it's negative one of those, take away another one of those, so that's minus 2 sine A, sine B. Okay, and that's everything I can control. Okay, now we're still quite a long way from what we're looking for, which is this. So the key thing is just keep the head with it and have a look at what we can do next. Okay, so I'm just going to remind myself of a couple of key things. Sine over cos is tan. Okay, I don't think I'm going to need that one because I can't see any division, but one that I think might be helpful is sine squared x plus cos squared x is equal to 1. So if I collect that sine squared A and cos squared A together, I think I can account for those and call them both together 1. Okay, next I'm going to go after sine squared B and cos squared B, and I'm going to put them together, and that is also another 1. Okay, now the next thing is I'm going to put this stuff together. So that is going to be 2 cos A cos B minus 2 sine A sine B. Okay, so the 1 and the 1 gives me 2. Now, what I'm going to do now is I'm going to try and use the final result to see where I go next. Now, the final result is asking me to take out a common factor 2. Right, so I'm going to take out a common factor 2 from here and here. And that's going to give me, in the same way that 2x minus 2y, that would then give me, well, 2 bracket x minus y. Well, in the same way, that will give me 2 lots of this, cos A, cos B, minus this, sine A, sine B. Because if we expanded that out, we would clearly get 2 cos A, cos B, minus 2 sine A, sine B. Okay. So, next move, I'm keeping my eye on the final answer. Okay, so I've now got 2 plus 2. Now, this should be familiar to you because that is the expanded out version of the cos plus expansion. So that's 2 bracket then cos A plus B, because remember for the expansion for cos you switch the sign. Okay, so we're almost there. Okay, so what I could do next is expand that open, and that will be 2 plus 2 cos A plus B, and then my final move, let's take out the common factor 2, and that will be 2 bracket plus 1 plus cos of the A plus B expansion, and that is the final answer. Okay, so we're going to try one more. This time we're going to prove that okay, so we're going to prove that cos 3a can be written as 4 cos cubed A minus 3 cos A. Now, if you think back to a lesson that we looked at the other day, and one of the things that I said is how might you write cos 15? Well, what we decided there is we could write that as a addition formula expansion, cos 60 minus 45, or for example sine 75, we could have written that as the addition formulae of sine 45 plus 30. Well, in a kind of similar vein, what we might say is that cos 3a could be written as cos 2a plus a. As to why we would decide to do that, I'm going to come back to that in a wee second. But remember that the cos plus expansion is cos sine sine, so it's going to be cos 2a cos a. And remember that if it's plus in the middle for cos, it becomes minus, so it's going to be minus sine 2a sine a. Now, why have I decided to do that? Well, the reason being is because as soon as I've got cos 2a and sine 2a, I can then kind of hark back to those formulas that I've learned for cos 2a and sine 2a, which I'm going to write down here just now. So remember that sine 2a is equal to 2 sine a cos a. Okay, let's try that again. This pen's giving me a bit of bother. So sine 2a is equal to 2 sine a cos a. Okay, that is slightly better. Okay, now remember that we've got 3 expansions for cos. So cos 2a is equal to 2 cos squared a minus 1. It's also equal to 1 minus 2 sine squared a. And then finally, it's also equal to cos squared a minus sine squared a. Okay, I'm making do it here without the pen, so that'll be that one. Okay, now, if I then look at what might be useful to me here, it's a wee bit of a mess, but we'll work with it. Okay, so what I would say is, let's look at our final answer. What is it we're looking for? We're looking for this. Okay, now the first thing that I would say is that I'm looking for stuff to do with cos. So for cos 2a, I've got options, which is this one, and this one. Now, I would stay away from that one and that one because they mix up cos and sine. If the answer looks to be all in cos, why don't I try and aim towards that? So I'm going to use that as an expansion. 2 cos squared a minus 1. So where I see cos 2a, I can replace it with 2 cos squared a minus 1. So that's what I'm going to do. Okay, so it's going to be 2 cos squared a minus 1. Now, as you can see, that is still being multiplied together by cos a. So I'm going to wrap a bracket around that, and that is getting multiplied by cos a. Okay, and you just need to pardon this as I do it with my finger. Okay, now, next one is I've got minus sine 2a times sine a. So if I bring the sine 2a back in, you can see that I only have one option for sine 2a, so I'll just need to go ahead and use that. So where I see sine 2a, I'm going to replace it with 2 sine a cos a. So that's going to be minus then 2 sine a cos a can see that that is getting multiplied by a sine A at the end. So I'm just going to wrap that in a bracket and write times sine A. Okay, and hopefully that is, it's a mess, but hopefully it's clear enough. Okay, right, so let's just see if I can do something with this. Okay, the first thing that I'm going to do is to expand, open this bracket. So that's going to give me 2 cos squared A times cos A is 2 cos cubed A. And then I've got minus 1 times cos A is just minus cos A. Okay, I've then got minus 2 sine A cos A times sine A, so that will be minus 2 sine squared A cos A. And a kind of useful parallel example to use. That one would just be if you had 2xy times y, you would, or 2xy times x rather, you would get 2x squared y. So that's basically what we've got there. Okay, so I'm going to again keep my eye on the final answer and I'm going to work towards it. 4 cos cubed A minus 3 cos A. Now, a good strategy at this point is to have a look at what you want to be in the final answer. Now, you want that cos cubed, right? So you're looking for 4 cos cubed A minus 3 cos A. So see that 2 cos cubed A, I think that's good. I don't think we want to do anything with that. I think I'm happy enough with that minus cos A because there is some cos A's in the answer. What I'm not so happy with is this sine expression here. So is there anything that I can do with that? So I'm going to try and substitute that out and swap it with something else. So let's have a think about that. Okay, now that brings me back to sine squared A plus cos squared A equals 1. Okay, so that was one that I wrote down earlier on. Now what I can do then is say then that sine squared A can be written as 1 minus cos squared A. Okay, and I'm going to do that here. So I'm going to write this line down again, but make that swap. So that's going to be 2 cos cubed A minus cos A. Okay, here's that swap now. So for sine squared A, I'm going to replace it with 1 minus cos squared A. Okay, so it's going to be minus 2 lots of 1 minus cos squared A. Close the bracket times cos A. Okay, I think we're starting to get places now. Let's see if we can just tidy this up. Okay, so 2 cos cubed A minus cos A. Okay, that's fairly straightforward. Minus 2. Okay, so I'm going to put that cos A over there. Bracket 1 minus cos squared A. Now, just to be clear that I haven't done anything that's that big there. Right, so you've got that times that times that. So A times B times C is the same as B times C times A. So all I've done there is rather than write it as that times that times that, I've written it as that times that times that. Not a big deal. Okay, I think I'm almost finished now. So let's go 2 cos cubed A minus cos A. Okay, I've now got minus 2 cos A times 1, which is minus 2 cos A. And then I've got minus 2 cos A times minus cos squared A, and that's going to give me plus 2 cos cubed A. Final move, let's collect the stuff together. That and that is going to give me my 4 cos cubed A. Minus cos A minus 2 cos A is minus 3 cos A, and that is the final answer. The key thing with these questions is you're always looking to make swaps and lifts.